Hi, everyone. What we're going to be working on today is the absolute value equation notes and lab. There's a couple of things we need to go over. First of all, some definitions, some important definitions, but also I wanted to just discuss what our expectations are, which is that these notes and the lab that goes with the notes, which is all in one document, needs to be filled in before, by the time this is due. We will jump right in assuming that you know what you're doing in class. So it's not something we're going to go over in class unless you have something you're unclear about, then you're ready to ask those questions. But it's important that you continue on in the notes. Don't come to one spot and be like, oh, I can't do this, and then just stop working. That's not how that works. You're going to just keep going. We need to make sure your notes are filled in so that we are ready to work in class. So we're going to do a bunch of problems, and we will be able to tell right away if you've done your notes, and also based on the questions that people are asking. And it's okay to ask. There's nothing wrong with that. That's the important thing. So we're going to get all the nitty-gritty mechanics out of the way so that we can get to the fun stuff in class. The first thing you're going to do is actually pause the video and do the do now. And it is really important to us that you fill in number 1 and number 2 the best way you can. Like, listen, if you make a mistake, you can erase it and fix it. It's not set in stone, but you got to try to think of this on your own first, and then we can correct and polish your definitions. So pause the video now, fill in the do now. I'll give you the answers when you turn the video back on. The most common definition for absolute value is this one here. This is probably the one you learned in middle school, that it's the distance a number is from 0. That's assuming it's on the number line, and on the number line it's all real numbers. And more technical definition that probably relates to science is that it's considered the magnitude of a real number without regard to sign. That means that, you know, if it's -5, the absolute value of that is 5. If it's +5, it's also 5, so you just ignore the sign. For the definition of what it means to solve an equation or an inequality, this one we're going to come back to over and over and over again this year. It is really important that you know this verbatim. It's one of those things you just have to know. It really is the foundation of everything we're doing this year. My guess is a lot of people wrote like, find the value for x or isolate x or all of those. Like, those are the common definitions that I hear when people give the first shot at it. The official definition instead is this. Your solving means to find all, so I'm going to highlight all, not just 1 or 2, but all of the values or of the variable or variables which makes the statement true. So here, we're basically this year, we're on a quest for the truth. Anytime you have an equation you're asked to solve, we are out there finding the truth. It's like almost, it sounds so deep right here. But what we're going to do is we're going to try and find values for the variable that makes the statement true. That's what I want you to think when the directions say solve. The last 4 answers down here. First of all, evaluating absolute value. You should get 3 for number 3 and 15 for number 4. And solving, now the directions in number 2 or the definition in number 2 really matters. We're trying to find all of the values for the variable that makes the statement true. So yes, you can substitute in a 4, but a -4 would also work to make it true. So in this particular case, and if I use proper set builder notation, the way this reads is that it's the set of all values for x such that x is equal to positive or -4. This notation is actually pretty important. You're telling me that you're solving in one variable and that both the value positive and -4 works for that variable to make the statement true. If you just wrote x like this, here, let me write it over here, x is equal to positive and -4, we don't know what that means. Because on the number line, yes, it's positive and -4, that would be true. But on the coordinate plane, if you told me that x was +4, it is actually a vertical line at +4. And that would mean that there's infinite infinitely many values or solutions to this, which is not what you're trying to say. So by using set builder notation, we narrow it down to, oh yeah, we're only on the number line, and therefore these are the only two values that work for this. Similarly, for number 6, we end up with x such that x is positive or negative. I wrote that wrong. It's supposed to be 6 here. Whoops. Positive and negative 6, like that, for that to work. All right. Moving on to example 1. Obviously, the note today is about absolute value. I brought in what it means to solve and some of those things because we're going to be writing equations and we're going to solve absolute value equations, and therefore it's super important that you know what it means to solve and also that you know what an absolute value is. So example 1, we're going to start with the conceptual methods of thinking of absolute value. Number 1 is that we're trying to find all the values for example 1a, values that are 4 away from 0. And remember, the absolute value means distance from 0. So we're trying to find the x values, some variable that are 4 away from 0. The way to indicate that is using absolute values. So we would have the absolute value is equal to 4. That would give me all of the values that are 4 away from 0. If I was to draw this, it would look like this. 0, and then we're counting 4 away from 0. That's both negative 4 and 4 are both 4 away from 0. So the solution set, when we graph it, looks like this on the number line. And if we were going to use proper set builder notation, it's positive and negative 4. Oh, look, it's question number 5 from the do now. Now, if I want some variation of this, for example, instead of going from the distance from 0, but I want the distance from 1, how does that change things? First of all, I want you to try and write an equation you think would do this. I can tell you that the answer is this here. I'll explain why it works in a second. But a couple of things. If I drew out what it's asking for, it's saying all the values that are 4 away from 1. So we center it at 1 and now go 4 to the left. That's negative 3. And 4 to the right would be positive 5. So I already know conceptually what these words are saying is asking me to find negative 3 and 5. Now that means if I substituted in negative 3 into that equation, this needs to be a true statement. So that means if I substituted negative 3 and subtracted 1, I would get negative 4. And the absolute value of negative 4 is actually 4. So yeah, that works. A lot of people mistakenly put in a plus here. Like they say, oh, it's x plus 1. But look, if I substituted in a negative 3 here, negative 3 plus 1 gives you a negative 2. An absolute value of negative 2 is definitely not 4. And the goal when we're solving is to make a true statement. So therefore, the only way that this would work is if it's x minus 1. In other words, I need to find the value I'm centering it at. What would make the absolute value equal to 0 at that value? So if I substituted in a 1, in here, I would get 1 minus 1 gives me 0. Now it's centered at 0. So this here is equivalent to centering it at 0 and going 4 from either side at 0. So therefore, for the next one, it says the values that are 2 away from negative 3. That means I'm centered at negative 3. I need to go 2 away in either direction. So the distance, which is this guy here on the end, outside the absolute value, is going to be 2. That's, by the way, negative 5 and negative 1. So I know it's going to be equal to 2. The problem is what goes inside the absolute value. Well, I need to make it so that I would get a 0 in there. So the way that I would find that is to take x plus 3, because if I substituted in a negative 3 in x plus 3, I would get a 0. And it looks like this here. Let's see. Oops, I accidentally erased that. X plus 3 is equal to 2. This means the way we read that is that the distance from negative 3 is 2. That's how to read that. Or the x's that are 2 away from -3. There's lots of different ways of reading that.